Hello, everyone, and welcome back to the Virtual Eclipse Community Meetup. I'm your host, Stephanie Swart, and today I'm joined by Thomas from Red Hat. Thanks so much for being here, Thomas. Today's meetup is called Unleash Your Talents, Server-Side Kotlin for Mobile Devs with Eclipse Vert.x. So without further ado, Thomas, take it away.
Thank you. So Kotlin is an alternative language which has become very popular in the mobile development community, and it is getting popular as well on the server side. So in the Vertx team, we've been working on supporting it since the latest version. We have even full support for it, including coroutines. So we have been thinking about how it can help mobile developers building backends. Is everyone able to see my screen?
Yep.
Okay. So from a mobile developer perspective, you can think of the full stack mobile developer, which has the responsibility to build not only the mobile application, but also the direct backend for it. So if you think of what we had years ago with the web development, you would have the agency writing a website for a client, and in many cases the agency would only write the HTML, the CSS, the JavaScript files, and just ask the client to maintain and develop the backend. And in the mobile development world, it's pretty much the same. It's pretty widespread that the mobile developer handles everything on the mobile side and delegates to the client as well. But that is not really optimal. If you think about the way we develop applications today, it's very common that you have a lot of services communicating together and using different backends, relational database, NoSQL services, etc. And the mobile application cannot be made responsible to connect to all these services. There are different kind of problems which may arise. One being that it's not very performant to hit all those services, and probably want to have something at the edge which is going to mix the content from those different services and pass it back to your mobile application in a compact and efficient way. So let's take a look at what an Android developer might have to master today. So there are a lot of devices that Android developer can target: phone, tablets, TV, cars, wearables. Many applications are still written in Java, more and more in Kotlin, but one tool that has been very, very popular in the mobile development community recently is RxJava. And we have now RxJava 2, which is fully supported by Eclipse Vert.x as well. A full stack mobile developer would have to master a server-side technology. Quite often, people just do some simple stuff with PHP or even Ruby or with servlets or pick the simple technology. We're going to see later in this presentation if there's nice solutions, a nice solution fitting the new programming model. They would have to master also some SQL or NoSQL technology. If you write an edge services, it's quite likely that you will have to store some data specific to your mobile backend. And of course, since services often communicate with HTTP over HTTP, a good server-side technology or mobile technology should have to come with a good HTTP client. Let me now introduce Eclipse Vert.x and how it could fit into this model. So Eclipse Vert.x is a toolkit, meaning that it's not a server that you download like you download a Tomcat server or Wi-Fi server. It's just a library that you add to your Maven POM file or your Gradle build file. It is used to build asynchronous applications. So all Vertx APIs are expose asynchronous API, so you don't block the calling thread. It is polyglot on the JVM, meaning that we support different languages. We have Java, of course. We support also JavaScript, Scala, and for what's interesting for us in this presentation, of course, is Kotlin. And it's used to build reactive systems, so systems where you want to be able to scale easily, to be fault tolerant, and resilient. So Vertx, it implements the reactor pattern, meaning that we have a single thread, the event loop, which will handle different kind of events. It could be an HTTP server, a buffer coming from an HTTP server. It could be a buffer coming from a database client, and you have all these events which are handled one after the other on the same thread. So you can. You probably have seen that in other tools like Node.js. It's the exact same principle. The difference with Node.js is that Vertx also implement what we call the Multi-Reactor pattern. So with a tool like Node.js, your process will be only able to make use of a single core of your CPU. And if you think about modern architectures, it's not a very efficient usage of the resources. CPUs today come very often with multiple cores, so you want to be able to make the most of your company hardware. Since you don't want to your different vertical instances to interfere with each other. With Vertx, in Vertx we have the Vertx event bus, which allows you to favor a message spacing style in your application architecture. So it supports different messaging paradigms. You can send a message from one Vertx application to another point-to-point, or you can use a publish-subscribe mechanism where one node would publish a message and every node would get it. Or you can also implement a request replying pattern. This is not very uncommon. It's something that you find in many messaging systems. And also the Vertx event bus has different bridges and clients. So the most used one we have in our stack is the WebSocket one. So basically it allows you to span the event bus over to another device, or a web browser, which is able to communicate over WebSockets. We also have a TCP bridge, And on top of those bridges, we have clients. We have one in plain Java, which can be useful for mobile development on Android. And we also have, for example, a Go client. One thing which is problematic for the Node.js community is that they start from scratch. You know, they have to rewrite everything. But in Java world, we have many libraries already to do many kind of things, from file access to database access. But the trouble is for us that most of them are built for a blocking world. Mainly, you can think about JDBC as the best example. And if you try to use an event loop system with such an API, then you will do something which is very wrong, which is blocking your event loop. And then as the event loop is blocked, you are no longer able to handle the new events. So basically your application is no longer responsive. So this is a big problem. So to circumvent that, in Vertx, we have developed a utility which allows to offload the blocking parts of your application to a worker pool. So when Vertx starts, there is a thread pool created, and you simply invoke execute blocking. And in this example, we have Kotlin making use of some API blocking method with the hello parameter. And this could take a significant amount of time, but at some point we will complete the feature when the result is ready, and then we will get the result as an event, and there we are back on the event loop. So it's a kind of nice tool and utility to be able to mix those two worlds, the event loop world and the traditional Java library blocking world. One question you could have for why using Java Kotlin, sorry, on the server side, especially as today's Java is definitely not the Java we have been using for years and years is that many Android devices support Java 8 constructs, but from only API level 24. And if you look at the market share, it's quite a majority of Android devices which are still with an API level less than 24. So we want to, to get nice constructs, but to be able to support older devices. And for the kind of applications that we write, like the microservices architecture we just saw, the benefits of Kotlin, the null safety extension methods, immutability, and the reduced verbosity are really handy, because they will help us to build applications that are easier to reason about. So before we get further into the demo of a more complex demo of Kotlin, I would like to show you how you can build a simple HTTP server with Vertx and Kotlin. So let's start with something simple. I hope you are all able to see my IDE now, correct?
Yeah.
Okay. So we will start by writing a simple class. And this class must extend the abstract vertical class. So this is the way in Vertx that you are able to kind of package your application, your services. So whenever you deploy a vertical to Vertx, Vertx will assign an event loop to it. And then every event generated from your vertical code will be handled on this event loop. So the same thread. The entry point for this class is just a start method, which you have to override from abstract vertical. And from there, you can simply create an HTTP server. If you want your server to do anything meaningful, you will have to provide a request handler. And here you can see how in Kotlin we can create callbacks very easily. The syntax is more Groovyish than Java-ish here. So whenever a request comes in, we will grab the response object and then just reply with hello world. Okay. From here, nothing happens because I have not told the server to listen to any port. So I'm going to use the Rx listen method, which returns a single from RxJava 2. So here, this is a lazy invocation. So when I call Rx listen on the HTTP server, nothing happens until I subscribe to the single providing the HTTP server. I don't want to do anything with the server here. I just want to say that the server is started. So with Kotlin, it's very easy to write concise callbacks. So here I don't even have to provide a parameter name since it's not used. So it's very this callback form is very compact. And in case something goes wrong, I still want to, see the error on the console. So here we should be good to go. Let's see that in action. I have written a Gradle build file here. So it uses the Vertx Gradle plugin, which has some conventions to build a Vertx application. I just have to provide a few dependencies, the Kotlin standard library, of course, and then I also need to add the Vertx land Kotlin dependency. Also, since I want to mix with RxJava 2, I added this dependency, and the rest of the dependency will come back to this later. I have a bigger demo where those will be needed, but for now, only lang Kotlin and RxJava 2 are needed. This Vertx blog just tells the Vertx plugin, the Vertx Gradle plugin, that the main vertical is the class which needs to be started. And this is just a convenient way to provide the Vertx stack version we want to use. Okay, let's go back to our terminal. So I see here that the console print started. So if I go back to my browser, I should be able to see hello world. Okay, so that was just to show you how, to give you a taste of Vertx with Kotlin and RxJava. But of course, this is in no way like a real application. So what we are going to do now is try to build a simple streaming music application as a mobile backend with Vertx, Kotlin, and RxJava 2. We are going to use the universal music player from the Google samples. It's an application written in Java. Unfortunately, I have not found time to port it to Kotlin, but here we're mostly interested in Kotlin on the server side, but so it's not that important. The important thing is that we are going to run this application in an Android device emulator and try to connect a Vertx and Kotlin backend to it. So basically, it gives it has a view which lists the kind of music you have in your library, and then you're able to start an application and switch start a song and switch to whichever position you like in the song, etc. How this mobile application works is that it first connects to music.json file on an HTTP server, and this music.json file must give you the list of tracks that you have in your library. Every track will come with a set of information: the song title, the image for the album, etc., and of course a URL for the track file. So what we will have to do is to create an endpoint to list all the tracks we have in our database, provided as a music JSON file, and in this JSON file we will provide the album pictures and track URLs. So just to give you a better idea of how this looks like on the wire, we'll have to create a JSON object which has a root music field, and in this field we have an array of objects. Each object here is a track, and so here it's just an excerpt, of course, but you will have the title, the source, which is the track file, and the image of the album. Okay, let's get started. So let's go back to my IDE. We're not going to start from scratch. I have prepared a repository which is available on GitHub. You will get the link at the end of the presentation, which has all the code. And today we are going just to take a look at the most interesting parts, at least from my point of view, of course. So what I have here in my project, first I have a db.sql file where I create a tracks table. Each track will get an ID, a title, album, artist. The source is the track file name, and also the image. To populate this database, we will use this import.sql file. So what I did here is that you have on the YouTube public music library, you can easily, like download public soundtracks, and they come with different metadata. So I just copied the file from there and prepared this these simple scripts and the insert to populate the database. Apart from that, I think that's the only relevant files. Oh no, in the webroot directory, I also added image for the tracks. So I got this quite easy. In some songs, I just set the Vertx project logo, and other songs the Kotlin project logo. And I also have media directory where all the track files are stored. And if you look at the source value for any track, it is prefixed with this media directory. So what happens is that when we will expose the static resources, which are here the images and the track files, they will be served from this reboot object. So that's why they are all packaged together in this reboot. So let's get back to the main vertical Kotlin file. So just as before with the simple HTTP server, we have this main vertical class, which extends the abstract vertical. We still override the start method, which is the entry point of our application. But you noticed already that we added a field here, the JDBC client. We use late init because in Vertx vertical classes we cannot initialize fields when the class is created, because it's only when the start method will be invoked that we'll be able to bind those variables. So Kotlin has this late init keyword, which tells us that we trust you to initialize this variable, and then you can you indicate the compilator that it should, take it as non-null. So that avoids to use the question marks everywhere, which is the workaround to work with nullable types in Kotlin. So yeah, this is the trick we have to use for Vertx vertical classes. Here at the beginning of the applications, we create a config object for access to the database. So this is the first Vertx specific thing for Kotlin that you can see. We have built a JSON builder API. So whenever you invoked this JSON block here, it will create an object which will map the key URL to this JDBC URL and the driver class to org h2 driver. If you want, you can just download the class and go to the sources. You will see how it uses Kotlin extensions to build this DSL, but this is beyond the scope of this demo. So the first thing we could do here is to initialize our JDBC client. So we will use the JDBC client class and create it with this config. So the JDBC client is a Vertx module to which wraps the JDBC API and offloads to a worker pool the any calls to the database. So with this with this module, it's possible to connect to any database which has a JDBC driver, but for full non-blocking reactive code, we also have a module which supports MySQL and Postgres databases without JDBC drivers. Okay, so now we want to init the app. What we want to do is first to run the script which will create the database, and then run the other script which will import all the data. And then we will set up the HTTP server, and eventually just tell just tell in the console that the server is started. So to easily run scripts, here we use the H2 database. This is the dependency I added in my Gradle build file. So this is just purely in memory. So whenever the application goes up, it will be created and then dropped when it goes down. So we have this run script function here, which allows to get a connection from the JDBC client and then execute a script that is H2 specific. So we can run any script which is on the class path. So we'll start with that, run script. And here we want to execute a script from the class path, is import.sql. This is the script, the db.sql. So this is the script which create the track table. So this returns an RxJava 2 completable. So we will tell that after the database has been initialized, we want to import the data. So again, we will use the script from the class path. And eventually, when the database has been fully initialized, we want to set up the HTTP server. So set up HTTP server, we'll come back to it in a second. It's a method which will create the Vertx router to handle the HTTP request and return a single with the HTTP server. So here, nothing again will happen unless we subscribe to the single, sorry. So we'll just say again that the server is started, and if anything goes wrong, we'll print the stack trace. Okay. Now, let's see what we can do to set up our HTTP server. So I said that we would initialize our Vertx web router. So Vertx web is another module from the Vertx stack. And to help you build HTTP endpoints, it uses this router construct, which is something you are familiar with if you have done some Node.js development with Express.js, for example. So instead of having your endpoints like in JAX-RS or Spring MVC, annotated with a path and a get or post method, you just declare the HTTP handlers on the router. So the first one we added here as an example is the logger handler. It's a built-in handler that will just log any request coming in. And one thing you need to know is that routes on Vertx Web are cumulative. So if you create different routes from the same path, they will be executed one, the handlers will be executed one after the other. So here, with this declaration, I am sure that the longer handler will be executed for whichever request comes to the HTTP server. So now let's build a handler for the music.json file. So I will ask the router for any GET request coming in for music.json file to invoke the list tracks method. And this list track method should go to the database, select everything in the table, and then map each line of the database to a JSON object, and eventually pack this up into a JSON array. So let's implement this method. We'll here again get a connection from the JDBC client, and then we'll flat map this with the Rx query method. What we want here is to select everything from track. So to keep it simple, we'll just select everything from the tracks table. So basically, as soon as we get the connection from the JDBC client, we will use it to execute this query. And once it's done, we will map every row to we'll map the result. Sorry, the rows from the SQL query result to the music JSON object, and nothing will happen here if we don't subscribe to the single. So what we have to do is to take the routing context, grab the response object, and just add the content type header to nicely indicate that this is JSON content. And eventually we will end by transforming this to a buffer, okay? So let's this up. We need to create the buffer like this. Okay, so what we'll do now here is we will use the JSON DSL builder as we did before for the config, and we'll just create an object which root is a music field, which itself is a JSON array. And we'll simply ask that for each row, we'll add track number. So we have to do this because the client wants those fields to work, but we don't have them in the database. So I just found that in my demo, and so I needed to add that as a workaround. Okay, so something is still wrong here. Let me find what's wrong. Yeah, that's it. So now my list tracks handler is ready. I should be able to finish the setup of my HTTP server. So I just again use Vertx create HTTP server, set a request handler, and whenever a request comes in, we will just delegate to the router to handle it, and eventually we just need to listen on the 8080 port, and that should be it for now. We are still not serving static resources, so we have to also handle GET request. Any GET request which is not a music JSON file with the Vertx static handler. So by default, this static handler will look for resources in the reboot folder. So this is where we have all our images and files. So let's go back now to our console. If everything goes right, application should start again. Here, the Vertx Gradle plugin rebuilds the application as we make changes. So, yeah. So now it started. It connected to the database. So everything should be okay. Let's take a look. If we go to localhost music.json, yes, it worked. We have a list of tracks, and you see that we have all the track IDs, the title, etc., as well as the images and the source. So it's time now to see how it looks in the mobile device. Let's see how that works. If I redeploy the application first. So here I have the universal music player cloned to an Android Studio as an Android Studio project. I just changed the catalog URL because by default it goes to a Google public URL, but here I just want to connect to the local HTTP server. So this IP address is just a simple way to tell the device to go to the host to my laptop. So let's see. I can browse music genres, and then I have different songs, and hopefully you can hear the sound. Can you hear the sound here from the music?
Yep.
Yep, great. And if you go back to the console here of the application, what you can see is that if I want to move forward in the song, the HTTP logger will tell me that it did a range request correctly. So this is the HTTP status code to indicate that we have successfully replied to a range request. So the static handler, which comes out of the box from Vertx Web, is able to do this for you. You don't have to download the full songs, and that's it. That concludes my demo. So just to give a quick recap on why you could be interested in using Vertx as a backend for your mobile application. It's proven. You can see on our website the many companies which use it. You have with the Eclipse Vert.x a threading model, the event loop model, which is familiar to mobile developers. You don't do any I/O with thread pools, which is quite good for mobile clients. Is the internet connectivity is not always good. And if you get lucky and your application gets popular, it's a backend which is really easy to scale on the same server or to scale also out by deploying different nodes. There is a full ecosystem, a reactive ecosystem around Vertx. Some modules we maintain them in the what we call the Vertx stack, which is the list of modules officially supported. And we also have a vibrant community contributing a lot of different modules in databases, caches, you name it. Thank you for watching this presentation and demo. You can go to the Vertx website. The code of the backend application is on GitHub with all the details on how to run it. And if you have questions later, which you cannot ask now, then feel free to contact me with my nickname either on GitHub, Twitter, or Gmail. And that's it.
Well, thanks, Thomas, for a great demo and a wonderful presentation. And of course, thank you to the community for tuning in. So it looks like we have one question from the community where Dennis asks, can you give a comparison of an actor model, example, a ka?
Well, Vertx, it implements very loosely the actor model. So if you think about verticals and the event bus, basically it's this concept of components using messages to communicate with each other, but compared to Akka, there is the event bus is a very lightweight mechanism. So it's on one hand it's easier to implement, and we do have users and contributor from coming from Scala. Just because of that, because it's easier to implement. But on the other hand, it comes with some less. I don't know how to say that, but it's a bit less reliable from this point of view. In particular, when the event bus is clustered, we do not provide any guarantee that the message will be delivered, and so you need to implement, like retries yourself, etc. So it's very lightweight and loosely implemented actors model.
All right, so that looks like all the questions we have for today. Thank you so much, Thomas, for doing the demo and presentation. And for everybody for tuning in, we'll be monitoring our chat box and Twitter feed and our meetup page. So if you have any questions, feel free to leave a comment on any of those, or of course on the YouTube video. And be sure to tune in next week or in the next 2 weeks for our next Virtual Eclipse Community Meetup. So again, Thomas, thank you so much for being here and giving an excellent demo on Vertx.
Thank you.
Thank you so much. Have a good one, guys.